Good evening, ladies, gentlemen, and of course, judges. Quick show of hands, who here has heard of graphene before? Nearly everyone, sweet. Okay, for everyone else, graphene is a single layer of carbon atoms arranged in a honeycomb or hexagonal pattern. And of course, when it was discovered in 2004, all the material scientists got in a real tizzy over it, but so did the computer and electrical engineers. They looked at this material and said, this could solve some of our problems. Specifically, as everyone knows, electrical engineers want better computers, faster computers, smaller, more powerful. And with this new, very thin, very flexible material, they thought maybe they could build this. Two problems with this line of thinking. One, graphene doesn't have a band gap, so you can't turn it on and off with an electronic current, can't get your ones and zeros. Number two, in a computer, you have to have wires, and wires are usually made of metal, and graphene don't like each other very much. So if you have a metal atom and it gets near your graphene, it tries to sit in the lattice, ends up breaking all your bonds, and your material disintegrates. Not great if your computer disintegrates when you're using it, obviously not. And this has been seen experimentally. You can see your lovely graphene lattice up here. You can see that you have bright aluminium atoms eating away and creating a giant hole. Worst case scenario. Thankfully, there are other 2D materials, including this, a transition metal dichalcogenide, or an atomic sandwich. You've got your heavier filling of your metal atoms, like molybdenum. You've got your bread, which is your lighter sulfur or selenium atoms, and it's already a lot more stable than graphene because it has 3 atomic layers. And it has an electronic band gap. You can turn it on and off with a current. And if metal comes near it, it just sits on top of the surface. It doesn't get destroyed by it. So of course, the next point of study is to get different types of metals and to put them near different types of these atomic sandwiches, because a couple of them exist, to see which ones work best together, which ones would survive having a current, and which could actually survive the real world. And to do this, a number of simulated experiments will be completed, as well as experimental electron microscope images, so that you can actually see all the atoms of the atomic sandwich and the brighter metal atoms, to study really by atom and by atom how they interact with each other to find the perfect new combination. Thank you very much.
Thank you.